Hello, viewers. All right, welcome to today's episode. Please do well to follow this page if you've not done that. Now, let's quickly look at this question here. The question is a bit lengthy, but I'm going to break it down step by step. And the question reads, listen, question reads, an excess copper is added to 25 cm cube of 16 mole per dm cube of nitric acid. We have to calculate the volume of the gas that is formed at STP. We are not told the equation of the reaction. We are not told the gas that is involved at STP, but we are asked to calculate for the volume of the gas at STP. And we are also given the mass number, the atomic mass of hydrogen to be 1, nitrogen 14, oxygen 16, copper 63. And we know that 1 mole of any gas is equal to 22.4 dm cube in terms of volume. Now, let's quickly write the equation first of all. We have to understand the equation. Copper Cu reacting with excess nitric acid, HNO3. Now, copper is a less reactive metal. When it reacts with an acid, it won't liberate hydrogen. Instead, the product form will be copper is going to be reduced to copper nitrate plus Na2 Na2 gas, and water in liquid state. This is aqueous state. So this is the gas that is formed. Now let's balance up that equation. Place 4 here, and hydrogen here is 4. Hydrogen here is 2. Place 2 here. Nitrogen here is 4. We have 2 nitrogen here. Place here 2 here. So I think the equation is now balanced. But our question is, what volume at STP will the gas be put? Now look at the gas here. This is the gas formed. This is the gas here. So what volume of nitrogen NO2 will be produced? Nitrogen oxide. First of all, we are also given some parameters in order to calculate that. We are told that excess copper was added to 25 cm cube. Volume of HNO3, 25 cm cube. I also told that the concentration of that same HNO3 is equal to what? They gave us the concentration 16 mole per dm cube. That's a lot of concentration there. 16 mole per dm cube. Now, we have to note that 1 mole of any gas, in this place, the gas is NO2, is equal to 22.4 dm cube. Now, we are told what will be the gas produced. First of all, what will be the gas produced as STP? Now, we have to ask ourselves, what is the mole of Na2 here? And what is number of mole? Number of mole is mass over molar mass, or concentration times volume. In this place, we are not told the concentration of the NO2. We are not told the volume of NO2, but we are told the volume of the acid being used. So let us use the acid, the number of mole of the acid, to calculate for the number of mole of the NO2, so that we can put this in this equation and then tell the volume of gas that will be involved. First of all, number of mole of the acid. Like I said, we want to calculate the number of mole of acid. So whatever we calculate for number of mole of acid, you can see the acid and the gas here, they are 4:2. So we are going to use the ratios in order to get the number of mole of NO2. Now, what is number of mole of nitric acid? Remember, number of mole is concentration times the volume in dm cube. What is the concentration of the acid? 16. What is the volume of the base? 25. Convert 25 to dm cube, get 0.025. So let's simply do that. 0.025 times 16. That gives us 0.4. 0.4 mole of the acid. Now we've gotten the number of mole of the acid. Now, from the balance equation, 4 moles rather, of nitric acid yielded 2 moles of NO2. This is from the 4 equal to 2 of the number of mole of the acid and the gas. Now, the number of mole we now calculated here, 0.4 of that same acid, will be equal to X. So what would be X? X will be equal to 0.4 times 2 divided by 4. We want to get the number of mole of the NO2 now. Let's simply do that. 0.4 times 2 divided by 4. That simply gives us 0.2 mole of NO2. So now we know that 1 mole of any gas is equal to this volume. Now the number of mole of NO2 we've got to now is 0.2. Will now be equal to Y dm cube. We don't know. Now how do we calculate for Y? Very easy. Y will be equal to this times this divided by 1, 0.2 times 22.4, and that simply gives us the volume of the gas that will be evolved, 0.2 times 22.4. That simply gives us 4.48 dm cube of the gas that will form, and the gas here is NO2. If you enjoy watching this video, make sure you drop a comment in the comment section, share to your friends, and have a nice day.